Okay, guys, so I'm here again talking about pH and pOH, and there's several conditions or considerations you have to account for. And the first thing you're going to want to look at is it a strong or a weak acid or base? And once you know whether it's strong or weak, those two decisions will take you different places. If it's strong, you can just directly calculate that pH equals negative log of the hydrogen ion concentration, and that hydrogen ion concentration will be equal to the concentration of whatever your acid is. Because the definition for strong acid is it completely dissociates. The same thing would be true for base, except for you would calculate pOH, which would be the negative log of the hydroxide ion concentration, and the concentration of your hydroxide ion would equal the concentration of your base as long as that base only had one OH. So if it was something like sodium hydroxide, you're good to go. That concentration would equal the concentration of hydroxide ions. But if it's something like magnesium hydroxide, now we have two OHs. And so the concentration, let's say we had 0.15 molar magnesium hydroxide. Since for every one magnesium hydroxide I get two hydroxide ions, the concentration of my hydroxide ions would be 0.30 molar. Okay, so that's not too bad. We get a little trickier when we're doing weak acid or weak base titrations or pH calculations because we have to write out that equation. So we have HA yields A plus A minus. We're going to do Rice. We have initial, change, and equilibrium. And let's say we had 0.010 molar here. When we first put everything in, we would have 0 hydrogen ions and 0 anion. We're going to lose a small amount from our acid because weak acids and bases do not completely dissociate. And I would gain a little bit of this, and I would gain a little bit of this. And so at equilibrium, it's going to be 0.010 minus x. We have x and x. And now if we wanted to figure out this concentration, so if you're finding pH, you would be given the Ka or the Kb. If you are trying to find the Ka or Kb, you would have to be given the pH. So, let's say we have an acid and its Ka is 1.8 times 10 to the negative fifth. So, this is a very small number. So that means I can assume that x is very, very small. Much smaller than 0.10. So then that would make my Ka would equal concentration of x over concentration of x divided by 0.010, which is going to equal that 1.8 times 10 to the negative fifth. So 1.8 times 10 to the negative fifth would equal x squared over 0.010. And now I think you can figure out how to solve these. It's pretty straightforward. So, what if I'm given the pH and asking to find Ka? So the question would be worded something like the pH of an unknown acid with an initial concentration of 0.050 molar is, let's say that pH is 3.015. What is the Ka? So we still have this kind of setup, only this number's changed. So at equilibrium, our concentration is going to be 0.050 minus X for HA. H would be, and I can find it from this pH. So how would I do that? So I have 3.0515 equals my pH. And so my hydrogen ion concentration is going to equal my anion concentration, because this is still true. These two have to be the same. And so to find my hydrogen ion concentration, it would be 10 to the negative 3.015. So 10 to the x is right above the log button. Second, 10 to the x negative 3.015. Did I do that right? Yep. Equals. And I get 9.66 times 10 to the, and I have 3 significant digits. The 3 decimal places are my significant figures. So this is going to equal 9.66 times 10 to the negative 4th molar. And so my Ka is going to equal 9.66 times 10 to the negative 4th molar times 9.66 times 10 to the negative 4th molar divided by 0.050 molar. Now I've made up all these numbers. Let's hope it comes out to something reasonable. And I want to square that. So second answer squared divided by 0.050 equals, and I get 1.86 times 10 to the negative 5th, which is going to be 1.9 times 10 to the negative 5th is equal to my Ka. And I ended up with 2 significant figures because this only has 2 significant figures. Hopefully you can kind of see all that. This is video 1. I will be making a second one in just a second.